This is a slide I like to show my students, and I just felt like talking something positive to you guys rather than just taking a lecture. So, what I want to say is that all of you might want to become successful dentists and make money, live a good life. But I want to ask you, do you love dentistry? Do you like doing dentistry procedures? Because you will be ending up chasing success if you don't like what you do. If you like what you do, if you're passionate about what you do, success will chase you. It is also a must that you should understand, like, admire, respect dentistry and the potential you have to change people's life. When a patient walks into your clinic with pain and when you relieve their pain, you're doing a service to the community. People have faith in you, they believe in you, and you have to stand up to that. And no matter how, but people come to you to solve their problem. So you have to strive hard to become more and more expert in whatever it is that you do. You're touching people's life in some or the other way, and that makes life very meaningful. So love dentistry and love to be a dentist. So the topic which we are going to talk about is dentin, and it is split in two presentations. So today we are going to discuss the physical and chemical properties and the histological structure of dentin, especially the types of dentin. Dentin determines the shape of the crown to most extent, and it physically and chemically has a close resemblance to the bone. The color varies from light yellow to darker yellow, especially in older people, it is darker in color. It is harder than cementum, but it is softer than enamel, and this is because of the difference in the mineralized component. And because it has a lower content of minerals compared to the enamel, it appears more radiolucent than enamel. And dentin is very elastic in nature, the reason why it bears up all the masticatory load and prevents the fracture of the enamel. It is composed of 65% of the mineral component, and that is made up of hydroxyapatite crystal, and 35% is its organic matter and water, which is composed of collagen, ground substance, proteoglycans, glycosaminoglycans. It is made up of structure called as dentinal tubules, similar to the enamel rods and rod sheath in enamel. So dentin is composed of dentinal tubules. They're called as tubules because they resemble tubes. They're nothing but empty, hollow structures which contain dentinal fluid as well as odontoblastic process traversing through it. Odontoblasts are present in the superficial zone of pulp, and they have long process called as odontoblastic process, which traverses the dentinoenamel junction, which crosses the dentinoenamel junction and passes through the dentinal tubules. So in other words, you can call dentinal tubules as the tubes in which the odontoblastic process traverses. This is the electron microscopic image of the odontoblastic process which is present within the dentinal tubule. During formation of dentin, the dentin is deposited between the odontoblastic process, and that dentin is called as intertubular dentin because it is between the two tubules. Another coat of dentin is formed at the periphery of these odontoblastic process, or you can say within the dentinal tubules. So it is called as intratubular dentin or peritubular dentin. So this is an image showing both of them. The black structures which you see can be referred to as odontoblastic process or dentinal tubules. The white halo structures is your peritubular dentin, and all this dentin between these dentinal tubules is your intertubular dentin. As the dentin goes closer to dentinoenamel junction, which is a scallop structure, it branches extensively, and this branching increases the density of the dentinal tubules closer to the dentinoenamel junction. Let's talk about the curvatures of these dentinal tubules. There is a primary curvature of the dentinal tubule which resembles the English alphabet S. This is nothing but the course of the dentinal tubules. But during the deposition, the odontoblast has slight undulation during its course, and this causes a waviness within the dentinal tubules, as you can see here. So these are called as secondary curvatures of dentinal tubules. So this is a histological image. If you take a closer picture, these are the dentinal tubules, and you can see slight waviness in these dentinal tubules. This is the predentin, which is the unmineralized dentin, always present close to the pulp, and these are the odontoblasts. Another classification of dentin is based on its location. So D is the circumpulpal dentin, which circumscribes the pulp, and C is mantle dentin, which is nothing but the first form dentin, and it is located closer to the dentino-enamel junction. On a radiograph, I've already told you, dentin appears slightly more radiolucent compared to the enamel, and it appears more radio-opaque than the pulp. Just a quick refreshment of your knowledge about the dentin and enamel formation. The odontoblasts are stimulated, which lay down the dentin. The dentin in turn stimulates the inner enamel epithelial cells to turn into amyloblasts, and these amyloblasts form enamel. So the first layer of dentin, when it comes in contact with the first layer of enamel, it seals to form the dentino-enamel junction, which is responsible for the mechanical bond between enamel and dentin. Coming to types of dentin, there is peritubular dentin, which is like a coat around the tubule in the periphery of the tubule. Intratubular dentin, it is also called as, because it is within the tubule around the odontoblastic process. Whereas the dentin which is deposited between the tubules is called as intertubular dentin. There is a layer of predentin present close to the odontoblast, which is unmineralized dentin. There is mantle dentin, which is closer to dentino-enamel junction, that's the first form dentin, and circumpulpal dentin surrounding the pulp. Two curvatures, primary curvature which resembles the English alphabet S, and secondary curvature which are waviness within the dentinal tubules caused by slight undulations of odontoblasts. I hope that's clear. Let's go to the multiple choice question. I want to ask you a question from the formative stages. So which of the following dental tissues are derived from the same embryonic source? The answer is dentin and pulp. These are derivatives of dental papilla. Enamel is derived from enamel organ. Cementum, periodontal ligament, and a part of the alveolar bone are all derivatives of dental sac. These are my references. So if you liked my presentation today, students, please share it with your friends, and kindly subscribe to my channel and hit the bell icon to get notifications of the new videos which I post and the new topics that you would like to see in my channel. You can put it in the chat box below or in the comments below. If you go to my website, you have notes or handouts for all these presentations which will be helpful for your exams, and there are multiple choice questions for you to practice so that you can stay ahead of your game. So thank you, take care, and keep smiling.